Okay, W is the number of weeks. And what if we want to find the number of days in W weeks, we take W and we multiply it by 7.
Yes.
Okay, so thinking kind of why that is, we take 1 week, we multiply it by 7. 2 weeks, we multiply it by 7 to find the number of days. 3 weeks to find the number of days, again, we multiply it by 7.
Yes.
If we have this formula W times 7, then we can take any number of weeks and we can multiply it by 7 to give us the number of days.
So if it was the number of 2 weeks,
Yeah?
it would be 14.
Yeah, so it would be 2 times 7. So we plug in, so we do something called substitution. We take 2 and we substitute W for 2.
Yes.
Okay? So it's kind of what we're doing with our sequences as well. If we're looking for the nth term, we're saying, okay, we don't know the number of the term, but we want a formula to get to that term.
Yes.
Okay? And this nth term will actually work for any place in the sequence.
Yes.
Okay? So using this sequence here, I'm just going to tidy this one up a little bit. It's got a little bit messy. Got a lot of writing on it. So we have 6n plus 18.
Yes.
How would you find the fifth term using the nth term? Using this formula?
Add 5. Subtract 5. 5.
So try using the formula.
Okay. So this is 0, and let me just say this part.
What
is
do you
0.
need to substitute in? Which part, sorry?
This part, this 18 is 0. It's the 0 term.
Yes, but don't look at the sequence. Don't look at the sequence. Just using the formula. How would you find the fifth term?
Minus 6n plus 18. Yeah.
That tells us the nth term. How about the fifth term? What does n represent?
Oh, the term. Yeah, the term.
Yeah, the term. So if I'm using minus 6n plus 18 to find the fifth term, what do I need to do?
And we need to find the fifth term, yeah. So minus 6 plus 18 is the which term? The 1, 2, 3, 4, 5
So
term.
what value, if I'm looking for the fifth term, what value should I put in here into the n?
Oh, 7. Because you see, the 18 is the fifth term, yes?
Not quite. Let me think. So each one of these guys, so let's get rid of the 18 for a second. Actually, let's go back to this example here. This is a slightly nicer example. Okay, so our nth term, so this is our nth term, is equal to 3n. Okay, so nth term is equal to 3n.
Yes.
So what that means is, because the nth term equals 3n,
Yes.
we can, every value we substitute in, we get the nth term when we substitute in where we are in the sequence.
So
So
6 is the second nth term. Yeah,
so the first term, what's the first term of our sequence?
3. No.
3. Yeah. So what happens if you substitute 1 into 3n?
2.
So I'm just labeling the terms. So if I substitute 1 into 3n, so n equals 1 is the first term.
Yes.
Okay. N equals 1 is the first term.
Yes.
So I substitute into the nth term 3, instead of n, I put 1. So I do 3 times 1 equal to 3. Okay? And that's the first term. The term where n equals 1.
Okay.
Okay? If I now want to find the second term, I do n equals 2. And I do 3 times 2. okay, which is 6. And that's the second term. How would I find the third term?
9, 3 times 3.
Yeah, 3 times 3. How about the fourth term?
3 times 4, 12.
Yeah, 3 times 4, which is 12. How about the fifth term?
3 times 5.
Yeah, perfect. 3 times 5, which is 15. How about the 100th term?
3,000.
So 300 was correct. Yeah, so it'd be 3 times 100, which is 300. Yeah, perfect. Okay, so I think we're getting the hang of this. Let's go back to this example here. So we're going to ignore the 18 because our real sequence, yeah, good. So we're labeling our terms. So let's have a kind of practice with the first couple of terms. So if n equals 1, what calculation do I do to find the nth term? So try using this formula here.
Can multiply 1. So 6 times 1.
Yeah, perfect. Minus 6 times good, plus
18.
18. Perfect. So if we actually work that out, we can actually see what's going on. So we'll do minus 6 times 1 plus 18 equals 12.
Yes.
Okay?
Yeah. Now 6 times 2 is 12.
Sorry?
6 times 2.
Yeah, now we do 6 times 2. So to find the second term, we do minus 6 times 2 plus 18. And what does the second term equal?
12.
Not quite.
6 times 2 is 12. 18.
So minus 12 plus
30.
8. Make sure so it's negative 6.
Oh, 10, 1, 2, and then 1, 0, 1. 6.
Yeah, perfect. So our answer is 6. Okay, so now let's try finding the third term using this method.
6 times
And we can check our answers on the sequence as well, because remember that this is the same sequence.
6 times 3.
Yeah, minus 6 times 3 plus
18.
Perfect. Yeah, well done. And what's that equal to?
0.
0. Perfect. And we can see in the sequence that we've got the correct answer. Now let's skip a couple of terms.
To 5.
Yeah, let's find term 5.
It's negative 12.
Yeah, negative 12. How would you find that using the formula?
So we're subtracting 6. So
Yeah, so using the sequence, that's correct. How would you use the formula to find the term?
negative 6 n times 5 and 18.
Yeah, negative 6 times 5. So instead of n, we put 5 plus 18, which is going to give us minus 12.
Yes.
Okay, good. Now let's do a little bit trickier. Let's do the 10th term. How would you find the 10th term?
So 6n times 10 and
It's
18.
minus 6.
Yeah, minus 6 and multiplied by 10 and 18.
Perfect. Okay, and what does that give us?
So 10 negative 30 subtract 12.
So negative 60 plus 18, which is?
10, 60 subtract negative 60 and 10 is equal to 50, so 42.
Yeah, perfect, minus 42. Exactly right. So what we notice here is that so we've just done one calculation. If we were to find using the sequence, the next 5 from the 10th term, we would have had to do the calculation 5 times, right? From minus 12, take away 6, take away 6, take away 6, 5 times, right? To get to the 10th term. So what the nth term does is it lets us have a much quicker way of finding that nth term.
Yes.
Okay. Perfect. So that's kind of what the reason of the nth term is. So why do I want to find the nth term?
So say if you want to find the 10th term, you can do negative 5 times 10, and it can show you by using the nth. So over here, and we just put it over there. So you can do, let's just put another number, negative 5n, yeah, add 15, yes,
yeah,
at 15, the n will show us, it's just, so it just, how can I put this in simple? So it just shows us where we're, where we
so
are.
it helps us maybe find the term that we're interested in.
So 5 times. So we want to find the 5th term. We can do 5 negative 5.
What's n equal to? If we're finding the 5th term.
50.
Just in general, what would you make n equal to if you were needing to find the 5th term? 5. Yeah, exactly right. If I'm looking for the 5th term, n is going to be equal to 5. If I'm looking for the 10th term, what's n equal to?
10th term, n will equal to 10.
Yeah. If I'm looking for the 3000th term, what's n equal to?
3000.
Yeah, exactly right. So what this nth term helps us with, as you were saying, is exactly right. So it helps us find those terms without having to go through the whole sequence. So we just do one calculation and we can get to the nth term.
Yes.
Okay, let's go back to this example here. So we're actually saying that our sequence, I'll just get rid of the 12 just because it's might confuse us a little bit. Let's start with one from scratch. So we've got 5 minus 2 minus 9 minus 16. So try and find the nth term here.
So 7 is the nth term. Subtract negative 7.
So take away 7 is the term-to-term rule. So if I'm looking for the nth term, how many times do I need to subtract 7?
2.
So that would give me the second term.
Oh yeah, we need to find the 7th. So let me just label 1, 2, 3, and 4.
Yeah, good. So before we try and find different terms, let's find the nth term first. So follow the rules that we were using before to find the nth term.
5.
We know that. So start with the term-to-term rule.
7, negative 7n.
Negative 7, yeah. Each time we taking away 7. And what do we put next? Yeah, perfect. We do minus 7n.
Subtract, I mean.
So it's always add, remember. Always add.
Add 12.
Add 12, yeah, perfect. So if we go back one step, we add 12. Good. Okay, so now if we want to find the 5th term, how would we find the 5th term?
Subtract 7 to 16, negative 16.
Good.
So 23.
23, minus 23, exactly right. Okay, what if we want to find the 10th term?
It's going to be negative 7. Negative 7 times 10.
Okay, good.
Is 70.
So remember it's negative 70.
Yeah. Yeah.
Good. Okay.
And then now we know. So now so